So good morning, students. Today we will be discussing the concept of threads along with you people. So at the very beginning, let me go to the slide view here. So today we will start our discussion with threads. So basically, what is a thread? Actually, we know that a particular a traditional process, is a particular address space and a single thread of control with which to execute a program. Now, to execute a program, a particular process has to initialize some uh, and maintain some sort of state information. So basically, those state information may include the process ID, the saved register values, file descriptions, page tables, and a lot of things that are somewhat heavier, we can say. So that incurs some sort of cost. So when we are dealing with processes, when we are creating more and more processes, so our related activities also increases. So basically, what we can do now in a multi-processor architecture where a lot of processes are being executed simultaneously, we can bring the concept of threads. So basically, a thread is a type of lightweight process. A thread is a flow of execution through the process code with its own program counter, system registers, and stack. A thread is also called a lightweight process. So basically, threads provide a way to improve the application performance through some sort of parallelism. Let me give a practical example. Suppose you are running a type of Word editing document. Suppose the particular user types something on the document and simultaneously a particular process has been running as a part of that package which provides some sort of spell checking facilities. So basically these are two separate execution activities being controlled from within a same process. So here we can say within the same process there are two separate execution sequences being executed simultaneously, and these two separate execution sequences, they are being referred to as separate threads. So basically each thread belongs to exactly one process and no thread can exist outside a process. So basically a thread must belong to a particular process only. The way we are maintaining process IDs, registers, all those things, in the same way, to create a thread, we also need to have some sort of thread IDs, process registers, all the thread registers, on all those allied values. So in the current slide that we can see now, so basically some diagrammatic representation is being shown to you. Single threaded versus multi-threaded application. So basically in case of single threaded process, we are having a single execution control, a single execution sequence, and the code, data, and files of the particular process are being shared. Uh, and in the case of multi-threaded processes, what is happening there? Code, data, and files, these are being shared by different separate threads. So these threads, they are maintaining their own stack and registers to work with. So basically, in case of multi-threaded processes, multi-threaded applications, separate execution sequences are being acted upon simultaneously by separate threads. So basically, now we'll see how a particular process and a thread differs. So coming to the first point, a process is heavyweight or resource intensive, and simultaneously, and in the same in the and with the same point, we can say that it is lightweight, taking lesser resources than a process. Process switching is more interactive with the operating system, but thread switching, it does not need that much interaction with the operating system. In the multiple processing environments, each process executes the same code but has its own memory and file resources. And in case of threads, all the threads, they can share some set of open files, child processes. And the multiple processes without using threads use more resources. Multiple threaded processes use fewer resources. And lastly, in case of multi-processing, each process operates can operate independently of each other. But in case of threads, one thread can read or change another thread's data. So they are somewhat interdependent on each other. Now, what are the basic advantages of threads? As I told you, thread is a lightweight process, so the context switching timing decreases in case of threads. Use of threads provides concurrency within a process. That is definitely true. The basic idea of using thread is to have separate activities running simultaneously from within the same process. It is efficient, it helps in efficient communication, and economy wise it is good for economy because it is more economical to create and context switch threads rather than processes. And in case of multi-processor architectures where there are several different multiple processors working in unison, we can schedule a thread in each of the separate processors. So that means mm, the concept of threads helps in achieving proper sort of multi-processor architecture features. So for example, in case of a single processor architecture, the threads all the threads cannot run in unison. That means we have to time slice between them. At a particular point of time, only one thread can be running. But in case of multi-processor architectures, where there are several processors available to us, we can schedule a thread in each of the separate processes. So that means that is definitely one of the major advantage of using threads. And what are the disadvantage of threads? The disadvantage can be like this: that if the parent thread gets blocked, the child threads also gets blocked. And from the security point of view, it is somewhat less secure. So basically, all I want to say is that right now nowadays several software packages are being run on the desktop PCs, and these applications typically they are implemented as separate processes with several threads of control. So just keep some points in mind that what are the particular benefits of using threads. One can be responsiveness. Uh, Multi-threading an interactive application allows a program to continue running even if one part of it gets blocked. Say, for example, suppose you are viewing a web page. Now, in that particular web page, some part can belong to textual format, some part can belong to some graphical image. So you may see that the graphical image takes some time to load, but the textual content loads instantly. That means there are two separate threads being working upon to display the information on your screen at that point of time. So these are some examples of where you can easily employ the concept of threads. Another point can be resource sharing, as I told you already that when you are sharing the code data and files, basically the things have been shared among all the threads of a particular process. Now it is good for economy also, and using threads you can definitely employ or you can definitely use the concept of multi-processor architectures in a more efficient manner. So that was all regarding the main features of threads. So in the next lesson we will study something more on threads. Okay, thank you.